Hello everyone, this is video tutorial 3.3 Bluetooth communication. In this tutorial, I'll teach you how to use the HC-06 Bluetooth module chip for the Arduino. Okay, as you can see here in my setup, I have a Bluetooth chip right here and then my potentiometer. I'll just use my potentiometer to send simple values through the Bluetooth communication port. So right now I have my Arduino actually connected to an outlet. It is not connected to my laptop at all, so I can't upload any code. I only connect it to my laptop if I'm uploading new code to it. So what's communicating with my laptop right now? It is the Bluetooth chip, right? It almost works exactly as how serial communication works. So what's communicating between my laptop and the actual Arduino is the Bluetooth chip. The Bluetooth chip works nearly the exact way how serial communication works, right? It receives a byte of data and then it can also transmit a byte of data at a time. So there's a lot of implementations that we can take from serial communication and include it in our sketch here for Bluetooth. This is an example from processing of a basic sine wave. We're going to use the potentiometer to control it. As you can see, I rotate my potentiometer and you can move the sine wave. It's a really nice effect, right? But very, very simple. This is just a grasp of the general principle of how Bluetooth communication works. You can use this in many, many different applications to record data over time wirelessly, to even make a wireless app to make a robot move, for example, right? Or you can even use it to control a wireless vehicle. Just a side note, don't think of an Arduino as, oh, it always has to be plugged into my computer, right? There's also a plug here where you can connect a battery towards, and you can also hook a battery into the pins over here. Just make sure everything's grounded by the Arduino. Right, my USB port is connected through a USB adapter to an outlet on the ground, as I mentioned before. So yeah, Bluetooth is very, very basic, and the HC-06 chip makes it very easy for you if you just want to get started on wireless technology. Before I jump into the code and all, I'm going to say that the code is fairly simple, but the process of connecting your chip, unplugging it, having it not upload, having it not reading, having the port busy, it's just a tedious process, so that I'm going to go over a few steps and precautions that I always take from experience with working with Bluetooth chips. Okay, so first I'm going to show you how to properly connect your Bluetooth chip to your device. In this case, it is my MacBook right now, right? So first, after my Bluetooth chip is wired correctly, I'll also show you the schematic in just a second right here. Okay, so if you follow the schematic properly, you'll have a few flashing lights on your Bluetooth chip. Right, you got a red one and a blue one. This, when it's blinking, that means it's waiting for a connection. That means it's not actually connected with anything yet, right? When the red light is steady, that means it's connected with something. That does not necessarily mean that anything is being transmitted or received through the port. Okay, so back to my laptop over here. I opened up my Bluetooth preferences and I can see the HC-06 Bluetooth module right here. So I'm going to go ahead and click pair. So after I click paired, it said a passkey entered did not match, right? So I'm going to go to my options, and the code by default is 1234. After I put 1234, I'm going to click pair. If you're on a Windows machine, open up, I think it's in the hardware settings, Bluetooth, and then you'll do the same process of putting in the code 1234. So it's going to say connected, and you got to make sure it is connected for it to work. Okay, so after it's paired, you can go ahead and run your sketch. So as you can see, I ran my sketch and then it's connected, right? Connected, everything's working accordingly. So I unplugged and plugged back in my Arduino and it says my device is not connected anymore. However, when I run the program, it connects it again. So sometimes this may do it automatically for you, and sometimes it might say the port's busy or the port's not recognizable. I'm not too sure why this may happen, but just for safe measure, make sure it's always recognized on your device list. Once it's recognized, it may be able to connect automatically for you. If not, just remove the device and then unplug your Arduino once again, plug it back in, and then you'll see it here again. Then you want to click pair and do the process all over. Once you do this process, it's going to connect automatically, and then you can see this icon over here. Oh, it's connected, and then you know for sure that it's going to run. Right? As compared to it not being connected and then running to make it connect, connecting it first will just be more safe. See, as you can see, this time it didn't work for me. Sometimes if you run it a couple times as well, it may be able to establish the connection, just like right there, see? Okay, these are just some of the precautions you can take while using the Bluetooth chip. I remember in my experience, I always had to unplug my device before uploading it, make sure it's unplugged, make sure there's no interruptions and all that stuff, right? It was a really tedious process trying to figure out, okay, what was wrong, what am I doing wrong, is it the code, is it the hardware? There's a lot of different factors that I had to take before learning how to use the chip. Okay, now I'm going to go over the code in Arduino, and then I'm going to go over the code and processing. Again, it's fairly simple, and it's easy to grasp. If you've been through the tutorials 3.1 and 3.2 already, this is very similar, but it's done through the Bluetooth nature instead of the serial port. Okay, let's get started with the Arduino code. Okay, so you can see here I have a new sketch, void setup in my void loop. I'm going to include software serial.h. Software serial, my serial 2 and 3. These are the 2 ports that we're connecting our Bluetooth chip with. And we initialize some variables here. Data sent. This will be my array and sending the 2 variables over the Bluetooth port. Int m pot pin equals analog pin 0. Int m value equals 0. Okay, so that's all the variables that we're going to need. And our void setup serial.begin 9600. This will initialize our console, our serial monitor, right? And then we're also going to initialize our Bluetooth communication. This is our Bluetooth communication. So as you can see, there's a difference. We have serial and my serial, right? So this will communicate between Arduino, and then this will communicate between our applications. You'll see later on why I decided to initialize both of these. So I'm just going to write right here in Arduino application external, or I'm just going to put out Arduino. Out of Arduino application. That makes more sense. Okay. Now I'm just going to map my values, or get my values, nlog, read. Again, we did this many times before. Pot pin, value equals map, value 0 to 1023 to 0 to 255, strain, value. I'm just going to make sure that the maximum values are between 0 and 255. Okay, I'm going to go serial.println and value. Okay, this is printing to over here, my serial monitor. It's not sending over the data just yet. I'm going to do this, my serial.listen. So this means I'm switching over from reading my serial port to my Bluetooth connection, right? I'm just going to put another comment up here. This is Arduino, and this is processing. Hopefully that makes more sense. Okay, now I'm going to write my serial.write. If you can see, I'm not using print line anymore. I'm using .write. .write means I'm going to write the byte of data instead of the actual chunk of characters, right? So if I use print line instead, it would actually send 2 characters. It would send the actual character and then a white space in between to tab to the next line. I don't want that. I just want my raw character itself. So I'm going to send over the letter A. You'll see why in just a second. Next up, I'm going to use my array to basically just organize myself better. Or to basically organize the data being sent better. Data equals 0. Data sent 1 equals, let's say 50. Okay. I got my 2 variables there. Now I'm going to send over my 2 variables. I'm going to cast them to make sure they're ints. I know they're already ints, but just to make sure, if I type in a character or so, and if I want to send an int, I'm just always got to type an int here. serial.write int 50. Delay 100. So that's not too fast. Okay, so the reason why I'm sending my serial.write A, because I'm going to use this A to initialize when to start reading my data, right? If you remember from lesson 3.1 and 3.2, sometimes if you notice, sometimes the data is in order when we send it over, but sometimes it's shifted over. So instead of going like this, instead of sending over 1, 2, 1, 2, 1, 2, it would sometimes give us this 2, 1, 2, 1, 2, 1, right? So it reads later than reading it exactly when we want it to, right? With this right here, I'm going to use this to say, I'm going to say if I read the character A, then I'm going to start reading 1, 2, 1, 2. So this will make sure that I will not get out of sequence right here, right? So I will always get 1, 2, 1, 2. So basically it reads it like this. If A, then 1, 2. If A, then go 1, 2. If A, then go 1, 2. So it's always going to do that. So it is never going to go if A, 2, 1, because that's not how I wrote it, right? Without this if statement, it can go like this, 2, 1, as I mentioned before, and that's not what we want. We want to keep it organized. We want to keep everything in sequence. Yeah, so this issue is more prominent in Bluetooth because I can start reading when I'm sending over this one, right? And then it would think this is my first one, and this one's my second one, right? And then it goes 1, 2, 1, 2 instead of going 1, 2, 1, 2, right? So again, in order to fix that, I'm going to put an if statement and say if I receive the letter A, then start going 1, 2, 1, 2, 1, 2. Right? So if A, 1, 2, if A, 1, 2, if A, 1, 2. That's the order we want to keep. Okay, this is it for Arduino. I'm going to move on to our processing code. Okay, now I have my processing software launch. Now I'm going to make my interface. So my interface is basically, I'm going to go to processing file, examples, and a list of examples will pop up. I'm going to use a sine wave. So it's under basics, math, sine wave. So I'm going to open that up. Put you over here. Here's my sine wave. This basically just draws a basic sine wave, just like that. Okay, so you see it's moving on its own right now. Now we're going to control it with our potentiometer wirelessly through Bluetooth. Okay, we're just going to add a few things here. We're just going to go down. Then we're going to import processing.serial dot star semicolon, just like that. And then import java nio dot byte buffer. Oh, I forgot an F. Byte buffer, sorry. Now we're going to go initialize our serial port. Serial my port float and data read equals 0.0, 0.0. Just like that. Okay. That's it. So now let's go to our setup. And now let's initialize our port. My port equals new serial this. See how it's nearly exactly the same as serial communication. But we're going to type in something else here. Go dev/cu dot hc dash 06 dash dev b. That is our Bluetooth communication port on my MacBook. Again, for Windows and for other laptops and devices, it's going to be different. If you want to view it, I'm going to open up my Arduino real quick. Right, if you want to view what your port is called, just go back to your port here, and then you can see it right here, right? So you can see my different ports. You see my iPhone, another Bluetooth port, and then my HC-06/DevB. That is my Bluetooth port. I'm just going to minimize Arduino just again. Okay, 9600, just like that. Okay, time to go into our draw. So we already have our sine wave written up for us, which is perfect, right? So now we're going to go if my port dot read equals A. This is to make sure that our data is read in order, right? So we go to while my port dot available is greater than 0. Right, open and close, and then for int I equals 0, I is less than 2, I plus plus. Open and close bracket, just like that. So now we have our three functions nested inside. Data read I equals my port dot read, just like that. So let's go. I'm just going to go over this real quick. So if we receive an A, and while our port is open, this is basically going to be true nearly all the time. While our port is open, if we receive an A, then we're going to start reading the next two functions that are gonna come over the serial port. In this case, we know that it's going to be around value because that is right after A, right? So this is basically making sure we're always going to start over here and then go here, then here, right? Remember before it sometimes started here, and then it just got all mixed up, right? So this will work nearly 100% of the time for you. Okay, I'm just gonna add a print line over here. Print line data read. What am I gonna say? Plus data. I'm just gonna print both the variables. Space bar right there. Data read 1, just like that. So it's just gonna print the two variables. Okay. So we have that. We have it reading the values, which is all fine. Right now, let's put that in our calc wave function. This right here is the one that's controlling our sine wave, right? So let's pass through mdata read 0. 0, remember 0 is the variable that's our potentiometer, right? Because that's the first one that we're going to send over. Float data read or float data, doesn't matter. Okay, now in here, I'm going to go data, I'm going to change this up, equals data. I'm going to go data equals, I'm just going to map it, data equals map data, 0 to 55, and then 0 to 3. I'm just making the number very, very small. Okay, now I mapped it out. How about let's also add our interpolation function as we used it before in 3.2. So I'm just gonna rewrite that real quick. So I'm gonna go float, interpolate, float A, float B, float amount. Remember we used this before. This is basically just to get a smoother animation. What did I do wrong? I don't think I did anything wrong. Okay, never mind. And I'm just gonna go return A plus B minus A times the amount. There's my interpolation function. Let me go. I'm gonna initialize another variable up here. Float enter. I'm just gonna float x theta. That's gonna represent my interpolation. So I'm just gonna go x theta equals interpolate x theta theta 0.1. So again, I'm changing this variable, making it smooth with the interpolation function, which will equal to x theta. So I'm going to change x theta over here. So I changed theta to x theta to make sure that I'm using this variable instead of this one. Okay, now that's about it. Let's go ahead and run it. Alright, I just took some time to make this record my full screen. Now I'm just going to run the code. Let's see if it works the first time. Oh, okay, look, it's connected. Perfect. So let's see if my potentiometer is working. My light has stopped blinking. That means it is connected. Rotate this. Oh, perfect. There we go. Okay. So yeah, it's all good and working. Now I'm going to explain why I did serial.begin and my serial.begin. Okay, so the serial.begin again initializes our serial monitor, right? So this basically has our first communication, right? And then my serial.begin initializes our Bluetooth communication, right? That is our second one. So we basically have it connected to two different communication ports, right? By default, the communication port for the serial.begin is 0 and 1. If I put 0 and 1 over here, I can't run my serial monitor and my Bluetooth communication at once because they're writing towards the same port. So that is why I used 2 and 3 instead of 0 and 1, right? In other examples, you might see that most of the time it always goes default to 0 and 1. In this case, we did 2 and 3, right? Another issue I found through experience is that if this was 0 and 1 as my Bluetooth, I would always have to unplug. I would literally have to take out my Bluetooth chip before uploading anything to it because the two communication ports always kept interfering with each other, right? Okay, so I'm going to demonstrate the interference real quick. Sometimes it might not upload if you have it the same as 0 and 1. And also, if I try to run my processing code, let's see. I still get a connection, but I'm not reading anything because it's thinking it's not reading the values at all, right? And I'm not getting any values because it's not getting any values at all, right? So I'm going to keep them as 2 and 3. I'm going to re-upload. I'm going to plug these back into 2 and 3. There we go. And then now I'm going to run it again. Oops. There we go, now I got my values reading again. And then I can also run my serial port once again. Okay, This is really useful for debugging because since my numbers or my data is being transmitted over a wireless connection, I want to make sure that I'm sending over the right data and I'm receiving the same data, correct? So as you can see here, it's 152 and it's 152.3 over here as well, right? And then as I change it, you can also see the change go on live, right? So it's 250 and then 255. Sometimes if you're really close or if you're really fast, you can see the bit of lag that the wireless connection has. So it's going to go to 0 first. I'm going to try this again. So it's going to go to 0 first over here. And then it's going to go to 0 over my processing, right? So let me try this one more time. So I'm going to quickly go to 0, and then if you watch the serial monitor, it's going to go to 0 first, and then it's going to go to 0 on my processing right after. Okay, ready? If you see that, it's really, really subtle. Very subtle, but there is a bit of lag, trust me. Okay, yeah, so this is basically it for lesson 3.3 Bluetooth communication. If you have more questions or concerns, I will explain further in detail how to debug, all the precautions, and how basically the Bluetooth communication works through the lesson. Thank you for listening, and have a good day.